This is the sugar content of various sodas lab. What we have here is various sodas. We have Coke, we have grape juice, we have orange soda, and we have some Gatorade. And we want to figure out what the sugar content of these different drinks is. In order to do this, we're going to be measuring their density. Density is closely correlated with sugar content. Sugar adds density to a solution, and so the more sugar a solution has, the higher its density will be. In order to find the sugar contents of the various sodas, we're going to first measure some standard solutions. So we have standard solutions that are 0, 5, 10, 15, and 20% sugar. And what we expect is that as we increase the sugar content in our standard solutions, the density will increase. You're going to make a graph with percent sugar on your x-axis and density on your y-axis. You'll plot the 5 points for the standard solutions, and then you'll draw a line of best fit, so a line that gets as close to those points as possible. Then you'll measure the density of the soft drinks, and you'll find their densities over here on the y-axis. You'll look over and you'll look down, and then that'll be an approximation of the sugar content of that particular drink. And you'll do that for 4 different drinks. So maybe one of the drinks is up here, and it has a higher sugar content. To begin with, we're going to find the density of just plain water. First thing you need to do is take an empty beaker and find its mass. So we'll put that on the balance, and it's 92.65 grams. That's an important mass because we're going to need to be subtracting that from the mass of all the other solutions, or all the other measurements. So 92.65 grams for the empty beaker. Now we're going to take, this is just tap water, this has no sugar in it, so this will be for our 0% solution. And we're going to measure out as close to 100 milliliters as we can. The density is not going to vary a lot between the different solutions, so we want to be as careful as we can with our measurements. We'll add a few more drops to get the bottom of the meniscus right to the line for 100. And we'll pour this into the beaker, and we'll find the mass of 100 milliliters of tap water. And we get 191.02. 191.00. All right, and we need to repeat this procedure with the other solutions. So we're going to keep this same beaker, and I've measured out 100 milliliters of a 5% solution. So I had a 5% solution mixed up, and we're going to measure out, or I've already measured out 100 milliliters of it. So we'll just pour that into our beaker. We'll find its mass, 193.54. 193.54 for the 5% sugar solution. And now we'll go on to the 10%. So this one contains 10% sugar. Again, we have 100 milliliters of it. We'll put it into the same beaker. 196.31. 196.3. Well, now it says 196.34. That was 10%. We'll try one with 15%. So we have 100 milliliters measured out again. You can see that the mass is getting slightly heavier as we increase the sugar concentration, and that's what we expected. Your graph is going to look like this, increasing density with increasing sugar percentage. For the 15% sugar solution, we have 197.86. 197.86 for the 15% sugar solution. 20%, this is our most concentrated solution, so we would expect this one to have the highest mass and the highest density. And the mass of 100 milliliters of the 20% solution is 199.48 grams. 199.48 grams. So with this information, you'll be able to calculate the density of each one of these solutions. And then with the density of these solutions, you'll create a graph that shows how density increases as sugar content increases. Now we're going to measure the density of some soft drinks, and we can use those densities to find the sugar content of those drinks. So we're going to start with Gatorade. This is the orange flavored Gatorade. We have 100 milliliters measured out. Put it into our beaker here. Put it on the balance. 198.41. 198.41 for the Gatorade. This is the orange soda. $195.30, $195.29.
Your attention, please. Nick Gintinelli, please report to the principal's office.
This is the Coca-Cola.
Please report to the principal's office.
So 100 milliliters of Coca-Cola. We'll find its mass, 198.44. 198.44 for the Coke. And lastly, we have the grape juice. Grape juice, 100 milliliters of grape juice, has a mass of 199.09. 199.08 for the grape juice. Okay, that should be all the data you need in order to calculate the density of the standard solutions, to make the graph, and then to approximate the percentage of sugar in the 4 beverages using your graph.